Hello again. Let's look at this example. D by dx of 5 minus 3x to the power of 100. There's a little typo down here that's bothering me. Let me correct that. Sorry about that. We'll get to that later. So d by dx of 5 minus 3x to the power of 100. Where 5 minus 3x, the whole thing is being raised to the power of 100. Remember, you replace 5 minus 3x with u. So that's d by du of u to the 100 times d by dx of the 5 minus 3x by the chain rule. Now d by dx of 5 minus 3x, the 5 just gets killed to 0. D by dx of negative 3, d by dx of negative 3x is negative 3. So when we execute the derivative, we get this becomes negative 3 upon derivating, and this becomes 100 u to the 99th power. The 100 comes down, and we subtract 1 from 100 and get 99. So we get that. Now, by the rules of arithmetic, 100 times negative 3 is negative 300. So we get negative 300 times u to the 99th. But we always want to replace letter u with x. So it's negative 300 times parentheses 5 minus 3x all raised to the 99th power. You do need these parentheses here. So there's that. And again, of course, from the get-go, u equals 5 minus 3x. That we needed that. We've been using that all along. Now this one down here, d by dx of you just do the similar thing, except u equals negative 5 minus 3x instead of positive 5 minus 3x. You just go through the same motions. I'll leave this one for you, and I'll also naturally leave this one for you right here. Okay, let's go down. D by dx of 5 minus 3x squared to the 100 power. That's going to be d by du of u to the 100 times d by dx of the interior, which is 5 minus 3x squared. Now, guys, when you do this guy right here, the d by dx of 5 minus 3x squared, the 5 just vanishes to 0. Now, d by dx of negative 3x squared, that's negative 6x. Remember that 2 jumps down and multiplies that negative 3, gives you negative 6. And then we subtract 1 off the 2 and get 1. We have x to the 1 power, but that's just x itself right there, okay? So we get negative 6x here, and then times the derivative of the u portion with respect to u. That's going to be 100 u to the 99th power. So we have 100 times u to the 99th power times negative 6 times x. But now by associativity, commutativity, and all that, 100 times negative 6 is negative 600. So we have negative 600x times u to the 99th. And this times sign right here is really superfluous, but I'll keep it. You could just as well put them together. Now, and it may be better to keep them separate like this anyway. We replace u with, remember, u is 5 minus 3x squared. And this, I didn't bother putting this in the box. This is a 5, this is a minus, this is 3x squared right here. So this is u equals 5 minus 3x squared. So I replace u with what we've been using this all along. The whole time u has been being 5 minus 3x squared. So here's u equals 5 minus 3x squared. So we replace u with 5 minus 3x squared right here and raise it. Now, so hence u to the 99th is parentheses 5 minus 3x squared, close parentheses to the 99th. And then so we have negative 600x times the 99th power of 5 minus 3x squared. So there's that one. And now this one I'll leave for you to do. Now this one, d by dx of 4 minus 3x to the 5th of the 100. Again, we do d by du of u to the 100th times d by dx of 4 minus 3x to the 5th. And now, guys, as before, we get 100 u to the 99th. Now, remember, d by dx of 4 is just 0. The derivative of the difference is the difference of the derivatives. And then 0 minus the derivative of 3x to the 5th. So in other words, what we're doing is we're doing d by dx of negative 3x to the 5th. That's going to be negative 15x to the 4th. So we have this guy right here times this guy right here. Now, by the rules of arithmetic, 100 times negative 15 is negative 1500. And then this x to the 4th, I just brought it right here. And then times, this times sign is really superfluous, but we'll keep it. So times u to the 99th power right there. Okay. Now, guys, here's the thing. Did I make a mistake? I sure did. Sorry, guys. That should be a negative 1500 there. I copy and paste, and I forget to change these things, so my bad. So that's a negative 1500 right there, and I'm glad I caught it not too far into the video. So that's negative 1500, and I do apologize about that. And again, the whole time u has been being equal to 4 minus 3x to the 5th power. So there's this guy right here, okay? And again, this is negative 1500, not negative 600. I copy and paste to make my life easier, but sometimes it makes my life harder because I forget to make the appropriate corrections for the germane into the next problem. So my bad. Let's look at the next problem, and I hope I didn't make any silly goofball errors. I've been slippery today for some reason. D by dx of radical 4 minus 3x to the 5th. We're not raising it to the 100 power, we're raising it to the half power. That's different. But the idea is kind of the same. You do d by du of u to the half, and then times d by dx of the interior guy right here. And again, d by du of u to the half is 1/2 u to the negative half by the power rule. Remember, the positive half comes down, then we subtract 1 off the positive half and get neg half here. And then we do d by dx of 4 minus 3x to the 5th. The 4 gets killed, and now the 5 jumps down in front of the neg 3, and we get negative 15 because we multiply the 5 and the neg 3 and get neg 15. And we subtract 1 off the 5 and get the 4 here. So it's negative 15x to the 4th. So we have 1/2 u to the neg half times neg 15x to the 4th. But now, a half times neg 15 is negative 15 halves. And then we have x to the 4th. Now, u to the negative half, that's the square root of u down here, downstairs. Okay, so we have negative 15 halves times x to the 4th over. Remember, we replace u with what u is, which is this 4 minus 3x to the 5th. So put that in there. And then now your professor, he or she, might be happy if you stop here. I mean, this is cool. This is really the right answer right here. But sometimes your professor, they're funny about radicals in the denominator. Some professors are. It depends on the professor at hand. My computer's acting funny. Don't pay any attention to it. But what we're going to do, guys, is if I stick another radical on the bottom, if I have radical 4 minus 3x to the 5th, and if I stick another radical 4 minus 3x to the 5th on the bottom, that would give me ordinary 4 minus 3x to the 5th. But I'd have to stick one up here as well. So I would get, and that would come up here multiplicatively with that x to the 4th. So I'd stick a radical 4 minus 3x to the 5th up here with that x to the 4th. And I'd stick a second one down here, but I'd have radical that times radical that. That would just give me ordinary 4 minus 3x to the 5th. Because radical 4 minus 3x to the 5th times another radical 4 minus 3x to the 5th is just ordinary 4 minus 3x to the 5th. That's the whole algebra 2 process of rationalizing the denominator. Now again, your professor, he or she might be happy if you just stop here. But he or she might want you to go all the way in to go here. It just depends on your professor's taste. And that was the step I skipped was a little bit, well, I explained what I skipped in words, but some students hate it when I do that. So here's the step that I skipped. If it will let me do what I want to do. Sometimes it can get real funny. What I did was I took this, we already had a radical 4 minus 3x to the 5 down below, but I want to stick another one down there with it, an identical twin copy. So what I do is I stick that guy down there, but I'm going to multiplicatively stick another identical twin copy down there with it. And and then what I'm doing is I'm doing this guy times this guy. I stuck another radical 4 minus 3x to the 5th down here. And I can do that, but the price I have to pay for doing that is I have to stick, well, my spacing is bad. It fragmented, it didn't bring my negative 15 halves down. Hold on just a second. Let it bring that down. And it's been a little bit difficult to get along with right now. So it'll bring it on down. Just give it a second. So there's that. Okay, there's that. I'm kind of used to the words bad behavior, but now I have to stick the same thing up here. I can't just leave the numerator unaffected. What I did was I stuck a radical down here and a radical up here, and I got this guy and this guy. But then radical whatever times radical whatever is just ordinary whatever right here. And then now this guy up in the numerator, we can't really do much with him. We just leave him alone. And by the way, that 4 belongs with that x. That's x to the 4th power times the square root. And guys, you can leave it like this if you wrote it by hand, but notice how Word obnoxiously sort of puts these together. You need to put a times sign just for clarity. That times sign deep down, it is superficial, but at the same time, syntactically, you need it just to show that this 4 belongs as a power of x and not an index of this radical right here. And I'm sorry for that aggravation, okay? But that's it. And I think, and again, u the whole time has been equal to 4 minus 3x to the 5th, just like it was up here, but except we're doing a different problem now, of course. Guys, that's all. I just had to go through some rowdy algebra to get what I wanted. Let's stop the video here. We'll move on to the next video. Thank you. Bye-bye.